Hi, thank you everyone. My name is Chris. I'm a postdoc at Arizona State University. These are a few of my collaborators that helped me out with this project. And I'm going to tell you for the next few minutes about different scenarios for the timeline of reionization. Okay, so I'd like to start with a 2-decade or more old question. Can galaxies drive cosmic reionization? And I'll just highlight a bit of recent work by Julian, pointing out that if you take some recent measurements of the UV luminosity function, the ionizing efficiency of high redshift galaxies, and you put that together with some reasonable assumptions about F escape inferred from lower redshift observations, reionization ends at redshift 9. There's some flickering here. Okay, so it would seem like the answer is yes, galaxies can drive reionization. So there are 3 possibilities. Broadly speaking, three possibilities here. Either reionization started early and ended early. That's the blue curve. This is a volume averaged H2 fraction versus redshift. Or maybe it started late and ended late, or started early and ended late. So these are 3 different representative reionization histories. These are the Planck optical depths for each of these models. And so what I did was to investigate these 3 different scenarios using radiative transfer simulations with my RT code FlexRT. Actually, thank you to Shekhar for talking about his approach to doing this, because it's basically the same thing I do, more or less. And the first result that falls out of this kind of analysis is that high redshift quasars observations require a late end to reionization. So this is the mean transmission of the Lyman alpha forest on the left, and the ionizing photon mean free path on the right, which are both things we've heard about earlier today. And you can see the comparison between a model that ends reionization late and one that ends early is quite dramatic, to say the least, showing that a redshift 8 end is very clearly disfavored. And of course, the reason is you simply produce too many photons and your IGM is too transparent. Much too transparent for observations. Okay, so now before I jump to the end, the other thing I did was to see if we could distinguish the other 2 scenarios, which are late ending reionization models with a late versus early start. And to do this, I looked at a whole bunch of different reionization observables. And this is the result. It's actually really very hard to tell. So you have a couple of observations from the CMB. You have the electron scattering optical depth and the patchy KSZ. You have several observations from high redshift galaxies. I'll highlight redshift greater than 8 Lyman alpha emitters, which we heard about earlier in the week, and also redshift less than 6.5 quasars, which we've also heard about earlier today. And the results are very mixed. None of these observables concretely rule out or confirm either of these scenarios, but there are different preferences that we find for these different observables. And what I just want to highlight is that there's one observable in each category, at least one, that prefers a later start to reionization. And so the conclusion I drew is that if you take all of these observables, put them together, you get a kind of a mild preference for a relatively late start to reionization around redshift 8 or 9. Unfortunately, this is a 5-minute talk, and I don't have time to go through all of these, but if you're interested, please talk to me afterwards. Thank you.
Great, thank you. And let's thank all the speakers of the session again.